We are continuing on with section 8.3, which was all about logarithms and logarithmic functions. Today our focus is going to be on graphing. Going to be focused on graphing. So you probably will need a calculator. If you don't already have one, you definitely need to grab one. You'll need graph paper, which you should have as your note sheet. This first slide is an example of what a logarithmic graph might look like. Remember when we graphed exponential functions? We had an asymptote, correct? Where was our asymptote located? Along the x-axis. When did that asymptote shift?
+1, plus minus.
If we were adding 1 or subtracting 1 from our function, correct? It shifted it up or down, and that caused your asymptote to caused your asymptote to change. In a logarithmic function, your asymptote is located along the y-axis. So in this case, our asymptote would be right here. Remember, your graph never touches that asymptote, it never crosses, it just gets closer and closer and closer. We see that it snuggles up next to it, but it never actually crosses over that asymptote. Here is our first example, which I believe you guys also have in your notes. We have f of x equals log base 3 of x. What does f of x really mean? Why? I'm going to start by replacing f of x with y. At this point, we have no idea how to graph a logarithmic function, do we?
No.
But we do know how to graph an exponential function. So let's change our log to exponential. What is the base in this equation? 3. Remember, your logarithm equals your exponent. What does this logarithm equal?
Y.
Y. So 3 to the y power equals x. Now, how did we graph exponential functions, guys?
X, Y, T chart.
X, Y, T chart. So let's do that. Now, in this case, am I going to pick values for x?
No.
It's not going to be easy to solve for y if you're picking them for x. You want to instead pick values for y, because it's much easier to take 3 to the 0 power, 3 to the first, or 3 to the negative 1 power, isn't it? Okay? So I'm going to, again, just like on exponentials, try 0, 1, and negative 2 to get an idea of what your graph's going to look like. So let's put 0 in for y. 3 to the 0 power is 1. So our first ordered pair is 1, 0. Try 1. 3 to the first power is 3. So our second point is 3, 1. Try negative 1. 3 to the negative 1 power is 1/3 or 0.3. 0.3, negative 1. Where did I tell you your asymptote is located?
Y.
Okay. On the y-axis, do we have a shift here? Are we adding or subtracting 1 to our function to 3 to the y power? Are we adding or subtracting 1?
No.
No. So our asymptote is going to remain here along the x, or y-axis, excuse me. Now, we could pick a few more points. We're not limited to picking 0, 1, and negative 1 for y. If we could pick a couple others, like say, let's put 2 in for y. 3 to the second power is 9. So our another ordered pair is 9, 2. The graph is doing something like this. And then this piece of the graph, you could go down. It's going to come down. Not that far over. It's going to get closer and closer and closer and closer and closer to that y-axis, but never actually touch it or cross it. On a quiz or test, I'm going to be very picky on your graphs. If your graph looks like it crosses that y-axis, I would mark it wrong. because we know there is an asymptote there, and your graph is not actually crossing that asymptote. It's just getting closer to it. Let's talk about domains and ranges here. What is the domain of this function? Okay, x is greater than 0. Do we have any values, any x values that are over here that are negative? Do we have any negative x values? We might have some negative y values, but we don't have any negative x values. So I agree with Trevor when he said that x is greater than 0. Why is it not equal to 0? It doesn't cross that asymptote, touch or cross, so it's just greater than 0. Let's go to our range. Okay? Now in exponentials, it was the other way around, wasn't it? Why do you think that is?
Different axes.
Logarithms, addition and subtraction. What do we call those two things?
Reciprocals.
Instead of opposites, what might we say? Inverses. Multiplication, division, what do we call those?
Inverses.
Inverses. Logarithms and exponentials, what do you think they are? They're inverses. Okay, we can use one to solve the other. The domain and range are going to be backwards of what you normally would see in an exponential. Any questions on this first graph? Let's go to example number 2 on your notes sheet. This time we have a fraction, which you cannot see. This time we have a fraction on our base. Not a big deal. We can evaluate with fractions. Like I said earlier, we can't do anything in logarithmic form. We need this to be an exponential. So our base here is 1/4 to what power? What is f of x? It's really y, so 1/4 to the y power equals x. So let's make an xyt chart. Again, is it going to be beneficial to evaluate by picking values for x or y? Definitely y. 0, 1, and -1 are a good place to start. Let's talk about our asymptote before we get too far. Where should our asymptote remain? On the y-axis. We don't have any shifts here, so it should remain right here. I like to kind of draw that in, if possible, at the beginning, so I know I'm evaluating my points correctly. Let's put 0 in. 1/4 to the 0 power is 1. So our first point is at 1, 0. Put 1 in. 1/4 to the first power is 1/4 or 0.25. Try -1. 1/4 to the -1 power is 4. We have a pretty good idea of what our graph is looking like. We can go ahead and kind of sketch it in. Remember, it doesn't actually cross that asymptote, it just gets closer and closer and closer to it. Why might you guess that this graph is opposite or flipped from the last one?
Fraction.
The fraction. Remember when we graphed exponentials, it did the same thing, didn't it? The graph looked a little bit different. Questions so far? So a couple more.
What about the domain?
Oh, thank you, Sydney. Let's do the domain and range here. What would the domain of this function be? Y is greater than 0? Domain? Yes, it should be x is greater than 0. That's right. What is the range? All real numbers. If you smash this graph along the y-axis, the range, is all real numbers. This next one is one to be done on your clicker. If you would please go ahead and